So I am going to put one of these on the test, but I know we've kind of been a little rushed through this section. So it will be one that's similar to a problem that I have done with you in class on the board. So if that helps, on the board or here on this video. So like number 11, the radius r of a circle is increasing at a rate of 4 centimeters per minute. That rate that the radius changes according to time was 4 centimeters per minute. Find the rate of change of the area. Find the rate of change of the area with respect to time when a part, the radius, is 8 centimeters. So we need a formula that deals with area and radius of a circle. So we have a equals pi r squared, and I do provide the formula that you would need. So we need to do implicit differentiation. So we have dA dt equals pi times 2r dr dt. dA dt is what we're trying to find. R is 8 and dr dt is 4. So the rate that the area is changing is 64 pi. And area is measured in square units, so this is centimeters squared per minute. Yeah, per minute. Number 13. I might have done this in class, I don't remember. The radius r of a sphere is increasing at a rate of 3 inches per minute. The radius is increasing at a rate, so that's dr dt, of 3 inches per minute. Find the rate of change of the volume, so find dv dt. When the radius is 9 inches. So I need a formula for a sphere that deals with radius and volume. So we can do the volume formula of a sphere, which I would give you. And we need to do implicit differentiation. 4/3 and pi are the constants, so we just need to do the derivative of the r cubed with respect to time. dv dt we don't know. R is 9. Whoops. And dr dt is 3. So this denominator 3 can reduce with one of these 3's. And let's see, 9 squared is 81. And 3 and 4 is 12. So I think the answer is 972 pi. And my units is volume, so that's a cubic unit, and it's inches per minute. All right, 15. All the edges of a cube are expanding at a rate of 6 centimeters per second. Rate. So let's see. Let's talk about our cube. Cubes are 3D squares, right? All the sides are the same shape and size. So, and it's a square, so this length and this length and this length are all the same. The length and the width and the height. So if I call that x, then the rate that the side is changing is dx dt, or the edge is changing 6 centimeters per second. How fast is the volume changing? Find the dv dt, the rate it's changing, when each edge is 2 centimeters. So when x is 2. Well, volume of a cube is side length cubed, or it's length times width times height, and all of them are the same. So the volume of a cube is x to the third power. So dv dt is 3x squared dx dt. Again, it's kind of odd that all three of these that we've done, the thing that we're trying to solve for is already by itself. Sometimes you have to get that by itself. We got the 2 squared, and dx dt is 6. What I meant was we're trying to find dv dt, and for each of these 3 problems, it's been by itself already. So let's see. 2 squared is 4. 3 times 4 is 12, and 12 times 6 is 72. And volume is measured in cubic. So this is centimeters, so centimeters cubed per second. Okay, last one. At a sand and gravel plant, sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. I don't know if you've ever seen one of these conveyors or not. I grew up on a farm, and my grandpa had a hayloft. That's a terrible barn, but he had a hayloft up here on the second floor of his barn, and he had this conveyor belt thing that he could load these square bales of hay onto it, and they would travel up to the top, and then somebody was up here and they could take the hay and they could stack it in the hayloft. So we've got that situation going on, except it's a conveyor belt that's loading sand. So sand is traveling up here, and then it's falling off the belt, and then it's making a pile. So you can think about it as it forms. It's going to form like a conical shape, like a cone. It's going to form this little pile here. That's what they're talking about. So we're dealing with cone. Let me see. Let's get back to the things they gave us. At a sand and gravel plant, sand is falling off a conveyor onto a conical pile at a rate of 10 cubic feet per minute. So if you're not sure what that is, you know it's a d something dt, look at the units. It's cubic feet, so that's volume. And it was 10 cubic feet per minute. There had to be some type of brace or support here too. It's kind of a crazy looking conveyor belt. The diameter of the base of the cone is approximately 3 times the altitude. So here's our better drawing of a cone. The diameter of the base is the circle that it sits on, and the altitude is the perpendicular height from the tip of the cone down to the center of the base. So it's the perpendicular height, and this should actually be dotted back here and solid. This is the altitude, and this is the diameter. And let's see, what did they tell us? They said the diameter of the cone is approximately 3 times the altitude. The diameter is approximately 3 times the altitude. At what rate is the height of the pile changing when the pile is 15 feet high? Find the change of the height when the height is 15 feet high. And it says the formula for the volume of the cone is 1/3 pi r squared h. Okie dokie. Let's see. We know that H. I think we're ready to get going here. So dv dt is 1/3 of pi times this. Oh, let's do this. So the diameter is 3 times the altitude, which is also 3 times the height. And 2 radius are equal to the diameter. So let's just change. We could either go into r's or into h's. I'm going to solve for r and do r equals 3 halves h. So right up here, I'm going to leave r squared, but instead of, whoops, I did that the wrong way. Let's solve for h. Try to get it down to one variable. So 2/3 r is h. Let's put that right here. Okay, I'm going to have to get rid of my picture of my bigger belt. So, and let's change this. I did some arranging, so I haven't taken any derivatives yet. Okay, and let's clean that up a little bit. 1/3 times 2/3 is 2/9 pi r to the third. Now let's do the derivative. dv dt equals 2/9 pi times 3r squared dr dt. dv dt this time is 10 times equals 2/9 pi 3 times r. Okay, we're going to have to use this and this, figure out what r is. So 2/3 of r is h, and h is 15. So multiply by 3 halves. R is 45 halves. So we'll put that right here. Squared. And dr dt is maybe I should have solved it for h first, because I want to find the rate of change of the height. Okay, I'm going to try to rework it without the video going. Okay, so if you're still with me, I reworked it because I realized when I was working it just a second ago that I needed to keep the h in the formula so I could do dh dt, and I had not. I had gotten rid of h and changed it all to r's. So I went back to this d equals 3a, and diameter was 2 radius. 3, h is the same thing as the altitude, and I solved it for r, and I got r to be 3 halves h. So I took the volume formula they gave us. R is 3 halves h squared times h. And that's 9/4 h squared times h. That's 9/12 or 3/4 pi times h to the third. Now we're ready to take the derivative. dv dt is 10. Let's see. 3 times 3 is 9/4 pi. H is 15 squared, and we're trying to find dh dt. Let's see, 9 times 15 squared. 15 squared is 225. That's 9. It's 225. if we flip this over and multiply by the reciprocal, it is a really tiny little decimal. It's, let me pull up my phone again. It's 0.019 or something. 0.0198. So we'll round to the nearest hundredths place. So 0.02. The rate the height is changing is approximately 0.02. And the units on this thing were feet per minute. This one's a little too complicated for me to do for a test question for us, just because of the fact about that diameter equals 3 times the area. That was a new little twist that they threw in there.